Okay, some of the last stuff from grade 9, different representation of lines. You must be able to go back and forth between the following ways that lines can be represented. From the equation to the graph to a table. Don't forget the table, or table to graph, or table to equation. So let's see how they match up. Remember, we got our slope. We got our y-intercept. So let's see, on the graph, we have our y-intercept. On a table, our y-intercept, remember x, that point is still a point. It's just a special point where the line crosses the y-axis. So that's still a point 0 and then a number. So x is worth 0. So our y-intercept, we look in the table, when x is equal to 0, what's y? There's our y-intercept right there. On a graph, our slope, we're going to pick two nice points, any 2 points. And use the y-intercept and the x-intercept, and then we can count. We can go 1, 2, 3, 4. It went down 4, and over 1, 2, 3, 4, 5. And we can have our slope is -4/5. On a table, to calculate slope, we do the same thing. We look from one to the other. Our change in y, remember our slope is our change in y over our change in x, or y2 minus y1 over x2 minus x1. So that goes down 3, down 3, down 3, down 3. Remember what this is called? Yeah, first differences. If we look over here, from -2 to -1, that goes up 1, up 1, up 1, up 1. These should all be the same. The change in y and the change in x, it's always the same amount. That means that is a linear relation or a line. That's one of the ways we tell. So again, slope, I can look at 3 and -3, the change in y over the change in x, 1. And we have a slope of -3. I also have my y-intercept, in this case here, of -1. Here, I found my slope, if I state my y-intercept, of 4. So being able to go between all of them. These two don't match up. That's okay. So let's see. Let's practice this. We're going to go from the equation to a graph. We've already done this. Easy peasy. We have our slope. We have our y-intercept. To do that, what I need you to show is I need you to actually state the y-intercept. b equals -5. Put it on the graph. I need you to state the slope. That's how you show me the workings that's going on in your brain. I can't see that. So slope of 3, remember, means up 3 over 1. 1, 2, 3 over 1. Up 1, 2, 3 over 1. If I go the opposite direction, from here, that's up 3 to 1. There we go. Just got enough points. Take my straight edge drawing tool. There we go. To do the opposite, we can look, what is, there it is. B is 3. I can state that there if I need to know. So that's going to be +3. And now I got to find the slope. Remember, that's going to go right in there. So let's find two nice points. I'm going to choose that one and that one. So let's see, I go down 1, 2, 3, -3, and I go over 1, 2, 3, 4, 5, 6. I've shown my work on the graph. So my slope is -3 over 6, which I can reduce to -1/2. Down 1 over 2. If I pick two closer points, down 1 over 2, there we go. So that slope goes right into the equation. If I don't count, I might choose my points and I might physically say y2 -1 minus y1, x2, 8 minus x1, -3 over 8 minus 2, 6. I get to the same spot. This is showing your work, or on the graph here, reduce. And of course I would reduce that and then put it in the equation. Okay, flip the page. To go from a table to a graph, again, I'm looking, do I have a y-intercept? There it is. I can state that. B equals 4. If I don't have a highlighter, I might just find it, state it, draw it on. For my slope, I think about from here, it goes up 2, and there it went up 1. I can pick any 2 points, and I can see my slope is going to be 2 over 1, which is 2. So I have a slope of 2, so I can use that, up 2 over 1, up 2 over 1, or I can actually just plot those points. -2, 0, -1, 2, 0, 4, 1, 6, 2, 8. Whoa, look at that. So I could always just plot those points, 1, 2, 3, 4, 5, they're there, 1, 2, 3, 4, 5. I don't even need to calculate slope unless I'm now putting it into an equation, which is down there. I got so excited, I got ahead of myself. Straight edge drawing tool, there we go. Other way around, graph to table, same thing. There's my y-intercept, so B equals 1, 2, 3, 4, 5, okay, so B equals 2. So if I'm just going to find a table, I can put any points in there. There's one, there's one, there's one, there's one. I can choose any 5 points and just put them in. So look at that, that's a point of 0, 2. Here's the point -1, 1, and here's the point -2, 0. There's the point 1, 3. Here's the point 2, 4. I can just use any points. I could use those ones, those ones, those ones, whatever. I would like to, maybe I could mess with people and choose like 3 in a row, this one, and then one really random. Doesn't matter. Equation to table. So as we started up there, we're going to pick 2 points and look at the change in first differences. So that's +1, and this went up 3. So my slope is going to be 3 over 1. I'm looking for when x is 0. Oh, I don't see it. So if this pattern follows, then I can expect that 0, which is 1 before, is the next step before. So I can kind of work backwards. So if this is always going up by 3, I'm going to go backwards. It's going to go down by 3. 5 take away 3 is 2. And there's my y-intercept. Now I have everything I need for my slope. Y equals 3x plus 2. Cool, 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 cool. Okay, equation to table. I could look and say, hey, here's my y-intercept, -1. That's when x is 0. I can choose any value for x, sub it in, and then solve. But if I know that my slope is -2, that means this is going to go down 2 each time. That means it's going to go down 2, the change in y, is going to go down 2, and it's going to go over 1, so the change in x is always going to be +1. So this is going to be +1, +1, +1. So -1 down 2, -3, -3 take away 2, -5, -7. Again, I could have just subbed in any values here, in for x, and solved. Okay, let's look at our table. At special lines, horizontal lines, and vertical lines. So horizontal lines, the horizon, all the way across, everything the light touches. So let's see. if I choose any points, there's 0, and that looks like 1, 2, 3, 4, 5, 6. And let's choose, say, 4, 6, and let's go the same way, -4, 6. Well, I got a y-intercept of 6. But if I look at my change, it's change of 0, and this is, I chose 4, but it's going to be anything. And so my slope is like 0 divided by 4, and 0 divided by 4, 0 divided by anything is 0. So my slope is 0. So y equals 0x plus 6. Well, I don't need to show that. 0x, so y equals 6. So any horizontal line goes across the horizon has the equation y equals 6, the y-intercept, because no matter what x is, y equals 6. Hey, when x is 10, what's y? Y equals 6. When x is -37, what's y? Oh, y is 6. So the horizontal lines, y equals whatever number that is. Vertical lines, let's do the same thing. Well, we don't have an x-intercept, so let's look at some of these points. Well, I got 3, 8. Let's go 3, 0. And let's go 3, we'll keep it the same, 3, -8. So if my change in y goes down 8, down 8, my change in x goes 0, so my slope is going to be -8 divided by 0. Put that in your calculator. Whoa, equals error. Huh. Maybe that explains the year we've had. We can't divide it by 0 equals error. There is no slope. This isn't going uphill, isn't going downhill. This is you are in every single place at that exact period of time. That's trouble, right? You're falling. If you want to think about slopes, you're falling. Error. So that means we can't even write it. And what's the y-intercept? Well, if it goes on forever, doesn't matter what x is, doesn't matter what y is, x is always 8. We're not going to have a y-intercept. So B doesn't exist. Doesn't actually cross. So because of that, no matter what y value it is, x always is 8. So our equation, just like it was y equals 6 over there, for any vertical line going up and down, x equals whatever the x-intercept is, which in this case is 3. Whoa. And that's how you math. All right, let's start with the fun stuff.